what is ACI? So I'm going to get a little techie here. So if you are a techie, tune in. If you're not a techie, maybe now's a good time to finish off your steak. But built on spine leaf topology. Spine leaf is a little bit different. The way we deploy a lot of data center architectures is the traditional aggregation layer, access layer, right? Aggregation access layer. It's the traditional way of architecting any kind of location, whether it's an office building or a data center infrastructure. We have the routing at the aggregation layer and the access ports at the edge. Makes sense. Really not very scalable. If I need a third work person in the room, want to add a third aggregation switch to their data center, why not? HSRP nightmares, or spanning tree nightmares. I mean, it's a problem. So spine leaf, we actually separate what's essentially backplane traffic onto spine switches that are kind of dumb, which is the opposite of, usually the intelligence resides at the core. You can kind of think of the spine as the new core. All of the intelligence is pushed out here now, and what we do is we scale out the leaf nodes as if they're access switches. So if I need more bandwidth in the environment, I can add a third spine switch a heck of a lot easier, and I can add a third aggregation switch. So a third spine switch comes up, connect up my leaves, and now I've got more bandwidth on the back end. Need more ports, add a leaf switch, connect it up, done. Okay, scalability, simplicity, it's a really good operating model. And the big one is, how are we doing that? How are we controlling and how are we managing this? Anybody have Nexus switches? This, Rich does. So do we. If you've ever managed a Cisco switch, a Nexus switch is no different, right? You got CLI access, you log in, you do config T, interface, Ethernet, whatever, switch mode access, et cetera, et cetera. This is a new day for Cisco. We are GUI access into the entire data center network infrastructure. What? Anybody Meraki? I keep asking these questions. All right, good. We got Meraki users in here. For those who don't know Meraki is Cisco's way of deploying cloud-based management solutions. So it's essentially your entire infrastructure, whether it's at one site or multiple sites, switches, wireless security, even phones now, all managed through one interface, one GUI interface. It's a phenomenal product. Definitely give us a call. We'll talk to you about it. And in a way, we take Meraki in this day and age, the internet age. I think internet memes give us this capability to take nouns and turn them into verbs, like Googling something. We're rocking our infrastructure. And so we can do the single GUI interface on the APIC down to the switches. So let's get that. So basically what we have here, and this is a picture from the NSI ACI environment. And yeah, we have, we see the topology, it's a little small there. But GUI, if I want to configure fabric policies, or it's the multi-tenancy from a security perspective, VM networking, et cetera. They're just point and click. You want to push a policy out to your entire fabric. You want to push a VLAN out, done. Change the QoS settings. Remember that tweak? Oh, my vMotion traffic is off-putting the iSCSI a little bit. Done. Okay, it's a new way of doing things. It's a new way that we can streamline processes, give us back a little bit more time in our day. Now, there are northbound APIs. Again, the word API, if I already lost you, then don't worry about it. But ACI is actually, anybody heard of software-defined networking? It's a term that's been tossed around for so long that nobody really knows what it means. SDN can stand for still don't know to some people. And it means something different to everybody. And the gist of it is, give my applications an interface into my networking. All right, an API, what an API does is allows two sets of software to talk to each other, or two different pieces of hardware to talk to each other. It's something that says, here's my APIs. If you want to have me do this, then send me this message, and vice versa, right? And so now we can talk to each other. Because software-defined networking, not everybody sees the value in software-defined networking, and that's fine. But again, it kind of opens a new path, a new way for us to do things. New opportunities. Plug and play, anybody? I mentioned earlier from a spine leaf perspective, right? I can put new leaf switches in and scale it out. How about if I plug a new switch in and it automatically pushes the configuration down? Your security policies, your VLAN information, your port configuration, virtual port channels even. This is huge. Meanwhile, by the way, and you know what's running in here? It's not Ethernet, kind of. Technically, it's embedded within Ethernet frames. But it's something Rich mentioned earlier. Has anybody heard of VXLAN? VXLAN is this, it's kind of a new way of doing Ethernet. How much do we love Ethernet, everyone? Isn't it like the worst protocol in the world? It was developed in the 70s, and it feels like you're watching a 70s movie when you're deploying it. What do? We try to make it better by deploying things like spanning tree, which is also sucky, virtual port channels, which were better, but still kind of sucky. We're always patching Ethernet. We're always trying to make it better. And our data centers go down because a spanning tree half the time fails. You know, I had a client that they lost 3 days because spanning tree failed. And their iSCSI traffic ran through their core, and so not only was their network down for a few hours, but all of the VMs had to be restored. Because guess what? I don't have to be a computer guy to understand that if I rip the hard drive out from a computer, that it doesn't like it. So when the storage layer is ripped out from underneath your virtual machines, they don't like it. And so they were hard down and in an impaired state for another 48 after that. That's no joke. So if we can remember that whole downtime conversation, right? If we can reduce downtime by deploying a robust fabric, and if your environment is small enough that you just need leaf switches, perfect. That's fine. If your environment is large enough that you need 20 leaf switches, even better. Actually, no, it's the same. Everything, by the way, from a topology perspective, notice is 2 hops away. If I need to get from this switch to this switch, hop, hop. If I need to get from this switch all the way down 20 switches later, same thing, hop, hop. So we also get a little bit of, consistency in our delivery expectations.